Okay, so our last thing is how we do integration with inverse trig. So we have to think about the derivatives of inverse trig. Do we remember what the derivative of arc sine of u was? Well, arc sine of u, remember, was u prime over the square root of 1 minus u squared. And the derivative of arctangent is u prime over 1 plus u squared. Now you probably are thinking, well, we also did arc cosine, but with integration, you always come down to either arc sine or arc tangent, because remember arc cotangent, or excuse me, arc cosine just had a negative there, so you could integrate it both ways. So here's the deal. When they're all mixed up, and your homework will be all mixed up as well, arc trig is not the first thing you think of. It's kind of a last resort, if you will, because if you see a quotient, I first think of u prime over u to see if it's a log. Then I think, well, maybe it's a power rule problem, or maybe it's a rewrite. So when it's none of those things and it has this form, then you have to think of the inverse trig. So that's when it's going to come into play. So just like with the e's, here's what you have to make sure of. Make sure you have u prime on the top. Because again, if the derivative of arc sine of u is this, then that means the integral of u prime over 1 minus u squared, that is arc sine plus c. And if I have the integral of u prime over 1 plus u squared, then that's going to give me arc tangent. But the point is you have to have that derivative of the u. So here's the deal. In example 1, to be honest, again, if I saw this on AP, I wouldn't go straight to the u to arc trig. I would think, is it an ln? But think about it. If this was an ln problem, and you don't have to write this down, and the derivative, or the u is 1 plus x squared, then the derivative would have to have an x. If this were an ln problem, I would have to have an x in the numerator. I can fix numbers, but I can't fix constants. So I have ruled out the fact that it's an ln. I can't do it as a power. I can't do anything else. So now I'm thinking of arc trig. And to me, it helps me to write it. If I think it's arc trig, I literally put parentheses and go, okay, if my u is now x, then du, of course, is just 1, right? 1 dx. So you have that. So how is this going to integrate? This is going to integrate, look what you really have. I have u prime over 1 plus u squared. And so what that is I would get arctangent of x plus c. And that's my integral. So, oh, interesting. Let's look at this one on the right. So this is the one that I have, and I purposely put these two together. Is that this is the one where, how cool that I have the du, I have the variable that I need. So how is the one on the right going to integrate? Well, you say either by your true u sub or your fast way. You're going to say I need 2x dx, so I'm going to need a 2. I'm going to pull a 1/2. So I would have 1/2 ln. Again, I could put the absolute value, but this is already positive, so I'm going to choose to not put it. And that would be my answer. So I want you to look at the next one on the bottom, and I will tell you that there's that floating dx that kind of shows up in problems. I don't know why. One of those is going to be an arc trig, and one of those is going to be a power rule problem. So the first thing I want you to do is I want you to see if you can integrate the one that is the power. So hopefully you can stop the video and think about it. Hopefully you said, well, this one is my one that's going to be the power. Because if I did this, what would du be? Negative 8x dx. And look, I have that x, so that's why he's there. So how am I going to do this problem? Well, I'm going to rewrite it as 1 minus 4x squared to the negative 1/2. I have x dx. What am I going to need? Well, I needed a negative 8. If I put in the negative 8, I have to take out the negative 8. This becomes my inner derivative. So now I can integrate the outer function, which is to the power of negative 1/2. So I increase the power by 1, divide by the new power. Dividing by 1/2 is multiplying by 2. I have a negative 1/8 plus c, and then that, of course, stays in there. So what do I get? For my final answer, I get negative 1/4, and I'd probably write that as a square root plus c. Now, how did I know this wasn't a log problem? I mean, I didn't go there because think about it. If I were asking, if you took the whole denominator of 1 minus 4x squared to the 1/2 power, man, you're going to have a square root with a derivative. So there's way more than what's going on there. So let's look at the one on the right. Okay, so the one on the right, if I solely had that problem, if I thought it maybe was one like this, where my u was 1 minus 4x squared, I'd say, nope, I need an x in the top. So it's not that. So that's when I think of arctrig. Now, if you had to guess which arctrig was it, well, is it going to be arcsine or arctangent? Well, clearly it's going to be arctangent, arcsine, because it has the square root. So if I do that, let me see if I can get it to look more like the form. It's 1 minus u squared. What would that u be? Well, 4x squared, that would be 2x. So my u is 2x this time. Therefore, do you see how with the arctrig, my derivative is just a constant. I don't need that variable of x. So now I'm like, oh, sweet. What do I have to have next to dx? I just have to have this 2. I need a 2 up there so that I would have u prime over the square root of 1 minus u squared. Well, if I put in the 2, I need the 1/2. So then all of this, I hope you see it, that what I have is u prime over the square root of 1 minus u squared. How does that integrate? 1/2 arcsine of your u, and what is your u? 2x plus c, and there's my answer. So I want you to look at both examples 3 and 4 and see if you can get those. So stop the video and see if you can get those guys. All right, what do we got? Well, for one, they put the dx on top. Again, we're not going to freak out at that. They can type it lots of different ways. I would first think, is this a log problem? Well, if it's a log problem and I look at the entire denominator, what would I need in my numerator? I would need an x because my derivative would be 18x. I don't have that, so I go, nope, not a log. So I might consider, is it a arctrig? Well, could I write it of the form 1 plus something squared? And oh, of course I can. I have 3x. So my u is 3x. My du is going to be 3 dx. So you're like, oh, sweet. To make it of the form that I need for arctangent, again, I don't have the square root, then all I need is a 3 on top. And if I need a 3 on top, then I have a 1/3, and now I've got it. U prime, 1 plus u squared, and so my answer is 1/3 arctangent of 3x plus c. So hopefully you got that one. Again, in example 4, I know I could think maybe it's a power rule problem. Don't write this down. If I think about, oh, I'll just move that 1/4 x squared to the top and put it to the negative 1/2. Remember, if I were trying to do the power rule, I have to have the inner derivative of this thing next to dx. What would I need? Well, I'd have to have an x. I don't have an x, so I can't do it that way. I never can get that green light to integrate the power. So I go, nope, it's not a power problem. Oh, maybe it's an art trick. So can I write it as the square root of 1 minus something squared? What would that something be? That something would be x over 2, or 1/2 x, however you like to write that, dx. So if my u is 1/2 x, you might see the derivative a little easier this way, then du is simply 1/2. So again, what am I missing in the top? I'm missing a 1/2. So if I put a 1/2 on top, what am I going to have on the outside? If I need to multiply to be 1, I'd have to put a 2 on the outside. So now I have it. U prime, square root of 1 minus u squared. That would be 2 arc sine, either x over 2 or 1/2 x, whichever way you like better, plus c, and you're there. All right, let's look at these. With these guys, what do we have? What do we have? Well, again, is it a log problem? That'd be the first thing I look at. How do I know that that one is not a log? Because if you look at the entire denominator, then the derivative of that denominator would be 2x minus 4. I've got an x, which I don't have in the numerator, so it can't be a log problem. So you say, well, I don't know what it is. Well, believe it or not, it's going to be an arctangent problem. You say, well, I don't see it that way. Well, you have to do something called completing the square, which you did in pre-cal, which you did in Algebra 2, but it's probably been a while. So we just have to make it look like an arctangent. So now I knew arctangent because, again, it doesn't have the square root. This is what arctangent looks like. So let me rewrite this guy. I'm just going to be clever in how I write it. I'm going to write x squared minus 4x plus blank plus 5 plus blank. People, I cannot change. I'm just going to put the dx on top just so I doesn't go over so much. I cannot change the problem. I cannot rewrite what this problem is and change numbers. I'm just writing that thing in a very, very, very smart way. Okay? I am going to pick, remember the completing the square. To put a number right here, you take half of this number, which is 2, and square it, and it would be plus 4. And the whole point of that is so that I can write it as something squared. Well, again, I can't change the problem, so I have to think of, well, if I put 4 in, then I have to take the 4 out because I really can add 0. Remember we said we can multiply by 1 or we can add 0. So if I put 4, I have to take out 4. Notice if I simplify this, I get this. So what is that really? Let me rewrite that. I have dx. Do you see that 5 plus negative 4 is equal to 1? I'm going to write that first. Plus, the whole point of you picking that to be plus 4 is so that if I said factor this guy, how would that factor? That would factor to x minus 2 squared. Well, look at that. Do you see that it is now of the form u prime over 1 plus u squared? Because if my u was x minus 2, what's the derivative of x minus 2? It's just 1. It's 1 dx. So I have, don't you have a 1 up there? So you have u prime 1 plus u squared. How does that integrate? Arc tangent of u. And what's my u? x minus 2 plus c, and there you go. Let's try, you try number 6. So stop the video and you try it. Well, again, I've eliminated, again, it's not going to be a log, it's not going to be anything else, so I think, oh, I bet it's that arctangent one that I have to complete the square. Now this 3, I just like to get him out of the way, so I'm going to just pull him out there. I'm going to do x squared plus 2x plus blank. I have the plus 2. That's what's in my problem. Now, what would I need to have to complete the square? Half of this number is 1. 1 squared, that gives me 1. So if I take 1 in, if I put 1 in, I have to take 1 out. And again, that would be 3 times the integral. That would be 1 plus, why did you pick this number? So that when I factor, I would get x plus 1. Notice when you factor, this is the sign that gets brought down. So see how this one is a minus, so it factors to x minus 2. This guy was a plus, so it's x plus 1. And honestly, you could probably see it. Your u is x plus 1. Its derivative is 1. So I have u prime over 1 plus u squared. I just happen to have a 3 on the outside. So I get 3 arctangent of x plus 1 plus c. And there you go. Now you might be thinking, well, what happens, gosh, what happens if this isn't a 1? I think in the problems that, yes, could I write a problem like that and you'd have to do some algebraic work? Yes. In the scope of our course, it will be nice. So it will get to a very easy, quote unquote, easy arc tangent problem. Let's make sure that we remember how to evaluate. So let's do number 7 and get an answer here. So again, with number 7, that 8 is just kind of in my way. I'll move him to the outside so that when I do, hopefully you see that integral pretty easily. Again, it's not a log because I need an x on the top, but I have u prime 1 plus u, think of it like that. If my u is x, its derivative is 1. So this is going to integrate to arctangent of x, and I'm going to evaluate from -1 to 1. So here's where, again, you have to remember how to evaluate these trig things, because if you had a definite integral, you'd have to get an answer there. So that's going to be equal to 8 times the arctangent of 1 minus the arctangent of -1. Well, let's see if we remember that. Remember, for both arc sine and arctangent, the good news is when you remember when you integrate, you get one of those two. For both of those two, you're going from -pi/2 to pi/2, and quadrant 4 is kind of the weird one. So let's see if we can evaluate this. Give me the arc in these two quadrants that has a tangent value of 1. So hopefully you'd say, oh, that's pi/4. Now give me the arc in those two quadrants whose tangent value is -1. Well, you know it's going to be down here in quadrant 4, but it's very important how you name it. You do not say 7 pi/4. You have to call it -pi/4. So what I really have there, plus positive, I have 8 times, well, that would be 2 pi/4. And of course, when I cancel, boom, boom is 2. I end up with an answer of 4 pi. So you do have to remember that quadrant, especially the quadrant 4, that you name it negatively. So that's how you do arc trig. So look for that as a last resort after you've eliminated ln, after you eliminate a power, and if it has the form of an arc trig, arc sine, or arc tangent, get there. Sometimes you have to do that completing the square. All right, good luck and peace out.